Okay, so the question is on number 32, projectile motion. Okay, so at least fresh in your heads, right? Doesn't mean you have, the best understanding of it or whatever, but fresh in our heads. So if a rocket is propelled upward from ground level, its height in meters after t seconds is given by h equals negative 9.8 t squared plus 107.8 t. During what interval of time will the rocket be higher than 294 meters?
So the formula isn't always the same.
Okay, so yeah, what I was just going to talk about, the formula. The formula we used in the notes and the problems in the book, if you go back and look, that problem was worked in feet per second probably. This one is in meters. So you're provided the formula, okay? It's not that you're having to memorize the formula, but it's a difference of the fact that negative 9.8, that is acceleration, okay, in meters per second as opposed to feet per second, which is the 16. Okay? So, provided formula. That's the good news, right? Now, if a rocket is propelled upward from ground level, there's the formula. During what interval of time will the rocket be higher than 294 meters? Okay, thoughts? Yeah, we're going to set up the equation, and instead of equals, though, I'm also going to say, I'm going to flip this. I'm going to say negative 9.8 t squared plus 107.8 t, and we want to know when it's going to be higher than 294, so I'm going to say greater than 294. In the book, you had 3 parts. One is it equal to something, less than something, greater than something. Here, we're just going straight for one answer. Okay. Thoughts about what can happen here? There's 2 things I would think of looking at this.
We gotta get that 0.
Okay, we need a 0 and coincidentally, they're all going to divide by the 9.8, aren't they? Okay, but both need to happen. Order-wise, it technically doesn't matter which happens first. If you want to go ahead and get equal to 0 first, that's fine. If you'd rather go ahead and divide first, that's fine. Okay? So, if we go ahead and do the 0 first, negative 9.8 t squared plus 107.8 t, subtract over the 294, so minus 294 greater than 0. I just looked at the answer key, and I'm doing this opposite order, but that's all right. Now, again, everything happened to divide by 16 in the notes and the homework. Well, it's just going to happen to divide by not just 9.8, but I would suggest negative 9.8. That way you don't have the negative left behind. Now, if I divide the first term by negative 9.8, we're dividing everybody by negative 9.8, including the 0. Okay? So when we divide these, well, the first one's t squared. I got that one. Positive divided by negative is a negative something t. According to my notes, it's 11. And negative divided by positive is plus. 294 divided by 9.8 is supposedly 30. 0 divided by anything is 0. What did I divide by here? Negative 9.8. What's that mean? Anytime you multiply or divide both sides of an inequality by a negative, you got to flip the sign. So this greater than just became less than. Okay? Now we'll still answer when is it higher than in the end, but for solving purposes, okay? Okay, so, and remember, we're really just trying to solve the equation t squared minus 11t plus 30 equals 0. That's what, as we try and go through this, we're just trying to solve that equation. As the others have, this one factors. T squared breaks into t times t. What multiplies to be 30 and adds to be negative 11? Negative 6 and negative 5. Officially set them each equal to 0. And we get answers of 5 and 6. I wrote 6 and 5 just because of the way mine's set up. Okay. So now keep in mind, this 5 and 6, these are actually going to be the times that our rocket is at exactly 294. Does that make sense? Because I turned this into an equal sign to actually solve it. And so this 5 and 6, this is a place where the height of that, a rocket, is at exactly 294 meters. So if I sketch you a parabola like yesterday, okay, the ideal projectile motion starts at 0, 0, it goes up, and it comes back down, right? Well, at some height, 294, it equals 5 and 6. And so those are the points where the rocket is at exactly 294 meters. So with that in mind, when is the rocket higher than 294 meters? Yeah, between 5 and 6, right? We're talking about this section right here. It's higher than 294 up here, which is past 5 seconds before 6 seconds. So really it's just up there 1 second. But in words, you can say between 5 and 6 seconds. As an inequality, you can say 5 less than t less than 6. But what we've been doing at most things in is interval notation, which starting at time 5, ending at time 6. So we're going to say 5 to 6. And this one just says higher than 294, so I'm going to use parentheses. Okay. And if you notice right here, when we actually had it equal to 0 and solved, this does become a less than sign, which means your answer probably is going to act more as an and statement, which is what happened here. Not that you really have to know that. You can just look at your, think about the picture and what's going on there. Does that help on that one? Megan?
For problems like 31 and 30, do you want us to sketch that graph? Or do we need it?
Okay, so the question was on 30 and 31, do you need to sketch the graph? So you're indicating because I sketched the graph in the answer key, right?
Yeah.
And you do not necessarily have to have a graph sketched. I mean, it's one of those things that if it helps you, then do it. If, you're okay without it, then you wouldn't necessarily have to do it. The only thing I can say on certain things is sometimes, if you give something up or whatever, I'm looking for ways to give you partial credit. The more that's shown, I might be able to get partial credit for than otherwise. But, the unfortunate problem sometimes when you don't have a lot of work to show, it just makes it hard for me to give partial credit. And I get it, because sometimes there's not a lot of work to show on certain problems. So, okay. What else? And in all honesty, I sketched that graph on 32. You wouldn't have to even necessarily have that graph on 30, 30, 31, 32. I sketched the graph just for helping with a level of understanding as I'm explaining it to people, but I'm not saying you'd have to have that graph to, get it right or anything. Peyton?
Can
We can. I wondered if we needed to, so. The difference between 30 and 31, let's see, 30 says to use algebra, so factoring to solve it, and then use the graphing calculator to check what's going on. 31 just says, it says solve by graphing. So if it just says solve by graphing, well, I don't know if you recognize this or not. Oh, this one actually would factor, wouldn't it? Don't count on that on the test. Yeah, this one does actually happen to factor, but can I look at 31 with you? And we can still backtrack and look at 30 if someone wants to also. But okay, so it says solve by graphing. First of all, before we can graph this, we need to make sure that it is, quote, equal to 0. In this case, I already have the 0 there, don't I? So that means we are going to graph. We're just going to plug it into the equation. We're going to graph y equals x squared plus 9x plus 14. So, you guys know the basics about graphing this at this point? X squared plus 9x plus 14. Who knows what your last graph looked like? So I would encourage you to do a zoom and go to a zoom standard. And we have a graph that looks like such, right? Now, because I didn't factor this, I don't officially know where my graph crosses the x-axis. And that's one of the things we have to know is where does it cross the x-axis? I just know I have this parabola here. So, like, you know, one of the first things you need to figure out is, okay, what are these points here? Where is my graph touching the x-axis? How do we figure out where the graph is touching the x-axis? What am I going to suggest we use?
Count, second, count, 0.
Okay, go into your second calc menu and go to the 0 option. Hopefully we're starting to get this one mastered. So if we go into second calc and the 0 option, so second, which is the trace button, calc, go to number 2. Now, pick one that you want to start working with at first, right? Try and zoom this in for a moment. So if I'm trying to find this one right here, gotta get my pen kind of in the right spot. If I'm trying to find that one right there, I'm trying to find that point where the graph crosses the x-axis. The question is asking left bound. So that means I need to move my cursor left of that point. So I'm going to arrow over, and to go left of that x-intercept, whoops, in this case, is going to be above it. But it's the left of it, yes? That's left bound. I'm going to hit enter. Then it's asking right bound. So now, this point where we're touching the x-axis, right, I want to move to the right of it. So I'm going to go through that point to the right of it, so somewhere down below in this case, and I'm going to hit equals. Now it's hitting guess. So I'm basically going to take my cursor back to where my pin is pointing. And I'm going to hit enter. And notice they're telling me that that 0 is -7, 0.
Now, if we're like anywhere in between, I've noticed like your guess doesn't have to be that accurate, does it?
No,
Okay,
it does not.
that's what I thought.
You're talking about like when you arrow back.
Yeah.
In all honesty,
move over a little bit, press enter, and then it'll give it.
in all honesty, I'm not even sure you have to move that cursor for the guess. Now, when you would have to is if you have 2 zeros inside your left bound and right bound or something like that.
Okay.
Then you have to move so you can tell it which one you want it to go for.
Yeah. Okay.
But from the, I mean, because technically I could set left bound and right bound on either way out and have both of these inside the same. Then my guess matters. But no, honestly, if you play around with it, you'll see that the guess doesn't really matter unless there's 2 choices. Okay, so we know one of these places is going to be -7. And then we repeat the process, yes? Second calc, 0. And that's the thing. Even if you set your boundaries real big, you still have to repeat the process twice because you can't find 2 at the same time. So this time I'm going for this point right here, right? So left bound is anywhere to the left of it. So anywhere before I cross through that, I'm going to say right there. Right bound is after it. And then this is what Carter was asking about. If I don't move my cursor back and I just hit guess, it likely will give me the correct answer. Okay. I say likely, 99% of the time probably. And so my other 0 is -2. Okay. So we know these values right here are -7 and -2. Okay. What was this question asking? Solve the quadratic inequality, but specifically what in this particular problem? On 31, it's greater than or equal to 0, which greater than or equal to 0 means I'm most concerned where this is above the x-axis. And yes, because it's equal to, officially you should be thinking on or above. Okay? So, where is my graph above the x-axis? It's those 2 outside pieces, right? So, in this piece on the left is to the left of -7. So that's kind of like saying x less than or equal to -7. This piece over here on the right is to the right of what x value? -2. So it's greater than or equal to -2. Because values to the right of -2 are greater than or equal to -2. I put equal to because the original problem had equal to. Now, how do I officially do this in interval notation? No. Well, what you just said, -7 to -2, would be this stuff down here in the middle. I need the stuff that is outside. Mm-hmm. Yeah. Okay. That's the answer I'm looking for right there. And again, I'm not saying you have to do a number line, but if that helps, you can even think, okay, what's this look like on a number line? It's going to go out this way, right? And out this way. So if it's going out, there's your -infinity to -7 and -2 to infinity. And my original sign was a greater than sign, wasn't it? Once I had this equal to 0 and everything, it was a greater than sign. So it makes sense that it's an or statement. Does that help some there? Yes. To an extent, because it's a greater than sign, you could assume it's going to be or statement, but I caution you because if it wasn't already equal to 0, that sign could end up flipping. Or like this one, we got it equal to 0, but we still had to divide by a negative, which ended up flipping our sign. So, I mean, you still need to be able to, that's the whole point of looking at the graph and checking. Okay. Yes.
So when we divide by 0, we cancel. Or not cancel, sorry. Flip the sign. How do we know when to flip the sign?
On 32, we divided by a negative, and that's what flipped the sign.
Okay.
When you multiply or divide both sides by a negative, that will flip the sign.
Okay.
So if that x squared had like 2 or something in front of it, we divide them all by. No, we wouldn't divide them all by 2, right?
No, you wouldn't. If you're going straight for the graphing calculator, you wouldn't. You could just have it as long as it has 0 on the right. It wouldn't matter what's in front of the x squared.
They're not going to have to flip that sign.
I don't think so.
But on one like 32, we should watch out for it. Okay.
Yeah. And 32 because it's that projectile motion and everything. So, but yeah. Okay. Got another one you want to look at real quick? I don't feel like we've gotten through many questions. We've talked about some good ones, so some important ones. It's on the same page here. What about something like 29?
Easy.
Easy?
Yep.
It's solve the inequality algebraically, write your solution in interval notation, right? Most of you got that in the quiz, but a few of you guys forgot interval notation. So, absolute value. Is the absolute value isolated? Yes. And so then we're going to set up 2. The first one is the given, x plus 5 over 4 greater than or equal to 5. What's my word?
Reciprocal.
What's the word I need in between problems? It's greater than sign, so I need an or. Then my other one, I keep the x plus 5 over 4, because I keep what's in the absolute value. Greater than flips to less than or equal to. Positive 5 flips to negative 5. You know how to set those two up, yes? Now, is the fraction tripping you up? If it's x plus 5 divided by 4, how do I deal with divide by 4? Multiply by 4. Whoops. And that's on both sides. Now, on the left, when you multiply by 4, it's like 4 over 1, x plus 5 over 4, so the 4s will cancel. And you have x plus 5 greater than or equal to 20. Subtract the 5, x greater than or equal to 15. Or, if it's x plus 5 divided by 4, we're going to multiply by 4. Multiply by 4 and a divide by 4 will cancel. So this time I have x plus 5 less than or equal to negative 20. If it's x plus 5, I can subtract 5. So x less than or equal to negative 25. Now, it doesn't say to graph it, does it? But if you need the visual, you can do a quick visual, can't you? There's 15. There's negative 25. We're going less than at negative 25. We're going greater than at 15. You don't have to have the graph, but if you need that visual to get your interval notation, there you go. So this is kind of like our interval notation we did earlier, wasn't it? Starting here at left arrow, negative infinity to negative 25, union, 15 to infinity. And there were brackets on the numbers because this was an equal to problem. Sorry. Okay, guys, practice, 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 study, study, study. Hit me up with questions before school, after school, homeroom, whenever you need it, okay? Know what you're doing. Calculators, pink papers are what you get to use tomorrow. Sure. Blue papers too if you want.
Just in case.
Which was the square root papers that your class asked for.